So today we are going to discuss about batteries. So batteries are mainly classified into primary batteries. Next, secondary batteries. See, what is a primary battery? Primary battery means it is only electrochemical cell. Secondary battery means it is electrochemical cell as well as electrolytic cell. So electrochemical cell means chemical energy. Chemical energy is converted into electrical energy. So here also electrochemical cell means chemical energy is converted into electrical energy. So after discharging, you put charging. So that means what? Electrical energy is converted into chemical energy. So this is called as charging. So chemical energy converted into electrical energy is called as a discharge. So the battery which acting as only electrochemical cell you called as a primary battery. So both electrochemical cell as electrolytic cell. It is happened, it is called as secondary battery. In the batteries, the main important is which is anode, which is cathode. So that is only main important. So I will provide one shortcut for that. So RG, GM high, Lecard high, high. Next, Kakam, Mayowak, Liowa, Niowa, Oxiva. So RG, GM high, Lecard high. So Kakam, Mayowak, Liowa, Niowa, Oxiva. So these first two you called as a primary batteries. Next, these three you called as a secondary batteries. So here, first one is a dry cell. Next, here. So in dry cell, anode is zinc, cathode is ammonium. Next, here, button cell. So in button cell, zinc amalgam is acting as anode, mercury oxide acting as a cathode. Next, here, lead storage battery. So anode is lead, cathode is lead oxide. Next, nickel cadmium. Nickel cadmium battery, anode is cadmium, cathode is nickel oxide. Next, so hydrogen oxygen, fuel cell. So these are in batteries mainly important primary battery. In entrance examination they will ask which of the following is primary battery, secondary battery. Otherwise in the dry cell which is anode, which is cathode. In button cell which is anode, which is cathode. In lead storage which is anode, which is cathode. Nickel cadmium which is anode, which is cathode. In fuel cell which is anode and cathode they will ask. So already we discussed RG, GM high, Lecard high. So Kakam, Mayowak, Liowa, Niowa, Oxiva. So first one we are writing a dry cell. See. So how the dry cell is prepared? See, anode is zinc, So the zinc tank, otherwise the outer surface you can take. So next, carbon rod. So carbon rod is acting as a cathode. Next, it is covered, it is separated with this is zinc, it is a negative. So cathode, anode, both are separated with a paper. Next, here, so carbon is surrounded, the carbon rod is surrounded with ammonium chloride. Ammonium chloride plus little amount it is added with anhydrous zinc chloride and MnO2. So this mixture is surrounded with the carbon rod. So that carbon rod is acting as a here cathode. Next, this is covered in a zinc tank. So that is, we are seeing normal use and throw battery also you called as that dry cell only. So at anode, what happens? At anode, so zinc loses electrons. Zinc become as Zn plus 2 plus 2 electrons. So already we know anode is what? Oxidation, loss of electron. You are getting oxidation. So at anode, oxidation is takes place. Next, at cathode. So at cathode, see what are coming outside, that is absorbed by cathode. So that means here, who is cathode? Ammonium. So 2 moles of ammonium attracting 2 electrons. So then what happens? So you are getting, so 2 moles of ammonia is coming outside. Next, hydrogen gas is coming outside. See, suppose you are taken only ammonium chloride. So then what happens? Gas is coming. So gas is coming means a cell will be, the size will be increases. So it is going to blast. So to control this gases, so that's why they are added with anhydrous zinc chloride. Anhydrous zinc chloride is absorbing ammonia. So then you are getting zinc NH3 taken 4 Cl2. So that is solid. So ammonia gas become as solid. So that means size is not going to increase. So the battery is a safe side. See, the zinc is a D block element, ammonia is a ligand. So D block ligand is there, directly you are getting complex compound. Next, the hydrogen gas. So that is MnO2 H2. This gas is absorbed by this one. So you are getting 2 moles of MnOOH. So you are getting a solid. So hydrogen gas become as a solid. So that's why again the cell will be safe side. So these two are important in the cell because of what is the use of anhydrous zinc chloride? Absorbed ammonia gas. What is the use of MnO2? Absorbing hydrogen gas. Next, second battery, we see button cell. So button cell. So here also, which is anode? Zinc is anode, cathode is mercury oxide. So direct at anode. So at anode, what happens? Zinc amalgam. So you can write zinc is loses electrons, Zn plus 2 plus 2 electrons. So here zinc amalgam is anode, hydroxide. Above high means that is hydroxide. So try to remember here. So hydroxide. Otherwise you can take zinc absorbing. So NaOH or KOH solution. So that's why you can take 2 moles. ZnOH taken twice plus 2 electrons. So in some books they will provide zinc become as Zn plus 2, otherwise some books they will provide like this. So both are same only. So anyhow, what happens, the electrons are releases. So at anode what happens, oxidation only takes place. Next, at cathode, so what are releases at anode, that is absorbed by cathode. So here what happens, gain of electrons are takes place, that is a reduction process here. So who is here cathode, mercury oxide, so HgO. So HgO is plus water. Next, that is taken 2 electrons. So then what happens, so you are getting mercury absorbs here Hg plus 2, absorbing 2 electrons, mercury coming outside. Next, so O and H2O, so you are getting 2 OH minus. So here OH minus, 2 moles of OH minus is absorbed, so that's why it is coming outside. 2 electrons are releases, so that is absorbed. So the problem is in this cell, the mercury is coming outside as a product. So mercury is releasing atmosphere means, so this is the poisonous nature. So poison too, it is a heavy metal, poison to our body. So button cell are the dangerous. So because of mercury is releasing in the after decomposition. Next we see the secondary battery. In secondary battery, first one, lead storage battery. So in the secondary batteries, in secondary battery, first one, lead storage battery. So what is anode, what is cathode? See, anode is a lead, cathode is a lead oxide. So here first a big tank is filled with concentrated H2SO4. So alternatively they are arranged, anode and cathode. See, this is a lead. Next, these are lead oxide, PbO2. These are connected alternatively. So all leads are connected with negative. So anode. Next, that lead oxide is connected with is a positive, cathode, and it is completely immersed with concentrated H2SO4 solution. So this is the original representation of that one. So what happens here at anode? So at anode, who is anode? Lead. So what lead is doing? Pb is loses 2 electrons. Pb plus 2 plus 2 electrons. So I am writing reversible because of secondary battery. So in chemical energy become as electrical energy, next electrical energy also become as a chemical energy. So that's why we are taken reversible. Next, where this is lead and lead oxide are immersed in concentrated H2SO4. So that's why Pb plus 2 is react with H2SO4. So then you will get PbSO4 plus 2H plus. So these two reactions are happened at anode. Next, you come at cathode. So at cathode. So who is cathode? PbO2, lead oxide. See, PbO2. See, who are coming in the anode, that is absorbed. Who is absorbed, that is coming outside. So PbO2 is absorbs 2 electrons. Next, so you remove 2 oxygens. So we are adding 4H plus. So then what happens? So Pb plus 4. Pb plus 4 become as Pb plus 2 plus you are getting 2H2O. See, electrons are outcoming, H pluses are coming out. So at cathode, electrons and H pluses are absorbed. Next, Pb plus 2, where it is immersed in lead sulfate. So Pb plus 2 react with H2SO4. So because of we are immersed in H2SO4 solution. So you are getting PbSO4 plus 2H plus. So this is the complete anode and cathode process. So now the total reaction we will write. Suppose total reaction we are going to write means what happens here. Pb plus 2, Pb plus 2 cancel. Pb plus 2, Pb plus 2. Next 2 electrons, 2 electrons. Right side 2H plus, 2H plus. Left side 4H plus. So that is completed. Cancellation. So what are that? Pb plus here PbO2 plus here H2SO4, here H2SO4, 2H2SO4. So that is double gives rise. So who are the products? Here PbSO4, PbSO4. So 2PbSO4 plus here remaining is what? 2H2O. So this is a complete reaction. So in examination also direct which of the following is lead storage equation. That to be here two important points are there. So lead is dissolved. So that means what? We are called as a discharge. So they will ask what is the discharge equation in lead storage battery. So Pb, PbO2, 2H2SO4, left to right you can write. Suppose charging. So we are putting charging means, so now reverse. PbSO4 become as Pb and PbO2. So left to right is discharging, right to left is charging. So directly they will ask which of the following is discharging equation, which of the following is charging equation. So you must concentrate. Next, in secondary battery, second example, that is a nickel cadmium battery. So nickel cadmium battery. So here, who is anode? So anode is cadmium. So at anode, so cadmium, what happens? It is loses electrons. So Cd plus 2 plus 2 electrons. Otherwise, high, cad high we are written. So that is high means OH minus. So you take Cd plus OH minus. So you can take CdOH taken twice plus 2 electrons. So that is at anode. Always. So it is reversible. So secondary battery. So that's why try to write a reversible manner. Next at cathode. So who is acting as a cathode? That is a nickel. So nickel oxide. So that is you take NiO2. So NiO2 plus water, H2O. Next here 2 electrons are coming. So you take 2 electrons. And they will provide, actually here nickel is plus 4. So you can, it become as Ni plus 2. So in some other books they can provide 2 moles of NiO. OH taken H2O plus 2 electrons. So then what happens here? 2 moles of NiOH taken twice plus 2 OH minus. See, you can easily understood. So at anode, 2 OH minus ions are absorbed. So here what? 2 OH minus ions are coming outside. Here 2 electrons are releasing. So that 2 electrons are absorbing. So you must concentrate. So here different books they will give different manner. So anyhow, nickel plus 4 become as nickel plus 2 in this. Cadmium 0 become as cadmium plus 2. Next, in secondary battery, last one. So, hydrogen, oxygen, fuel cell. Hydrogen and oxygen fuel cell. So, here, who is anode? Hydrogen is anode. Next, cathode is oxygen. So, in this process, so we are taken a rectangular shaped. So the tank you can take. See, this is a porous membrane. So here NaOH solution. So the middle chamber is filled with NaOH. NaOH solution. Otherwise any KOH solution. OH minus is important for us. Next, it is connected with anode, negative charge. Another one connected with cathode as a positive. So we rectangular tank we are taken. This is converted into two chambers by using porous membrane. By using porous material we are separated. So here anode is contacted with hydrogen gas. We are sending hydrogen gas here. Next, here cathode is contacted with oxygen gas. So what happens here? So at anode. So at anode, hydrogen. So hydrogen, see from here OH minus ions. OH minus ions are coming through the porous membrane. So hydrogen combining with OH minus. So it is reversible. So then what happens? 2. You are getting 2H2O plus 2 electrons. 2 electrons are coming outside. Next, at cathode. So at cathode, electrons are absorbed. Who is at cathode? Oxygen. So oxygen absorbs water plus 4 electrons. So then what happens here? So 2 water molecules, 4. So you will get 4 OHs, 2 oxygens, 2 oxygens, 4 oxygens, next 4 hydrogens, they will attract 4 electrons, you will get 4 OH minus. So always you think the logic, who are coming outside, here added. Who are added, that are coming outside. So now try to balance this one. So here what happens? So 4 electrons are coming. Here 2 electrons are coming. So for balancing, this is multiplied with 2. So anodic reaction. So anodic reaction multiplied with 2. So then only it is going to balance. So that means 2H2 plus 4OH minus. So double gives rise. So 4 water plus 4 electrons. Next, here at cathode. Cathode is what? O2 plus 2H2O plus 4 electrons. So gives rise to 4OH minus. So complete reaction you write. So here 4 electrons cancelled. So here 2 water, here 2 is 4OH, 4OH. So what happens? 2H2 plus O2. So double gives rise to, you are getting 2 moles of water. So what happens here? The important, the byproduct means current is coming, current is the main product, byproduct is water. So here the importance is the useful water. Useful water is available as a byproduct. Next, there is no pollution in this. In this one, no pollution is available. Next, third, efficiency is very high. So that's why this hydrogen oxygen fuel cell is a powerful one. So but actually the problem is hydrogen is easily catches fire, oxygen is easily catches fire and is also explosive. If you control the hydrogen and oxygen reactivity and explosive nature, so it is the wonderful one. Next important concept we are going to discuss, that is corrosion. Next, one important corrosion. So which is corrosion? Corrosion means which material? Suppose you take iron. Iron you put in atmosphere. Slowly it is become as rust. So the rust is removed from the metal surface. Again, fresh metal is contacted with atmosphere, that is going to damage. So continuously the metal strength is decreases. That only we called as a corrosion. So anodic material. Anodic material. So that is readily corroded because of loss of electron. So oxidation is takes place. The material which is readily oxidized. So otherwise which is acting as anodic material, that is readily corroded. Means metal strength is decreases. So the best example, so iron corrosion. Suppose you take iron bar you take. Suppose iron. So sharp edges contains charge is more. So this is covered with atmospheric gases. So atmospheric means what? Water is there and oxygen. These are the famous. So here also water, otherwise oxygens are attracted. See, iron is what? Metal. Iron is a metal. Atmosphere is non-metal. So that contains what? Water vapor, oxygen, nitrogen, these all are what? Non-metal. So metal has what? High electropositivity. Non-metal has what? High electronegativity. So that's why they are continuously reacted with each other. So if after reaction the outer material is removed, means you called as corrosion. If outside formation of any compound is strongly attracted, means that you called as passivity. That is safest side the material. So here what happens? Iron. So iron is acting as anode. So means iron is loses electrons. So you are getting Fe plus 2 plus 2 electrons. So iron. So Fe plus 2. So is a react with water. So then what happens? You are getting FeOH taken twice plus hydrogen gas is coming outside. Next, FeOH taken twice. FeOH taken twice. Here also oxygen is powerful is there. So oxygen is there, water is there. So that's why it is water. These are powerful oxidizing agents. So that become as FeOH taken thrice. Next, that FeOH taken thrice is loses water. So that become as Fe3O4. So this is called as rust. So iron oxide is forming. See, iron oxide formation and it is stick on the iron. So no problem. But actually there is no attraction between iron metal and Fe3O4. So that is coming outside. So when Fe3O4 is coming outside, Fe3O4 is forming on the surface of iron metal and it is coming outside. Then what happens? The fresh metal is contacted with atmosphere. So the metal strength is continuously decreases. So that you called as corrosion. Next here, how to control the corrosion? So how to control the corrosion means one, you put organic paints. Organic paints are using on the surface of metal. Next, so iron is coated with zinc. Iron is coated with zinc. This is called as galvanization. So in entrance point of view, so very important, in the galvanization process, which metal is which one is coated with iron surface? So that is zinc. Next, who is corroded? Anode is corroded. So anodic material, anode is corroded. So who is safe side from corrosion? So cathode is safe side. Cathode is safe side from corrosion. So that's why whatever the material, suppose you want to protect iron, so the iron you convert into cathode, so iron will be safe. So that is a safe side from the corrosion. So the best example, you can take the underground water pipelines. Underground water pipelines, otherwise oil pipelines. So it is what? Made up of with iron only. It is easily corroded. So that's why this is connected with magnesium pit. So more and more magnesium is connected. So in our shortcut, Likka Namalji Fekaduko, magnesium is left side. Left side means this is anode. So iron become as a cathode. So then what happens? The cathodic material is a safe side. So iron is a safe side from the corrosion. So nowadays that water pipelines are coated with cement also. So that is somewhat of useful from the corrosion. So now better one. So more and more important means the pipeline importance means you must connected with magnesium pit. So then it will be safe side. Next, here last concept, passivity. See, this is opposite of corrosion. See, suppose the best example you take aluminium. So aluminium is a metal. So suppose you put outside on the atmosphere. So the atmospheric gases, so what are that? Water is there, oxygen is there, nitrogen are there. So these atmospheric gases, so they are readily reacted with aluminium. So these are reacted on aluminium and they will provide so aluminium compound. So that means that is either aluminium oxide also forming, otherwise aluminium nitride also it is possible. So what happens after formation of this compound on the surface of aluminium, their attraction is more. So this material is not coming outside. These compounds are not coming outside means inner aluminium is not exposed to atmosphere. So the aluminium is a safe side. So the best you can see our current wires, they will put aluminium wires only. Suppose starting what aluminum wire, it is shining, it is there. After some days, the rain is coming and they are reacted, they become as brown color. So, and that outside layer is secure the inside of aluminum. So that is called as a passivity. Suppose this compound is coming outside means that is called as corrosion. Whatever the forming compounds strongly attracted with metal, you called as a passivity.